by substitution, some part of which we have discussed in the previous class. So as you know that if the integration is having two functions and suppose gx is the derivative of this x, f dash x dx is equal to gx. So in that case, that means d by dx of this gx is f dash x. Then I will substitute one of the function as t. Now let us take the example. The question is integration e to the power a tan inverse x over 1 plus x square dx. So you can see that it is having two functions, product of two functions. This is f, exponential a tan inverse x, and 1 upon 1 plus x square is the second function. Gx is 1 over 1 plus x square. So the tan inverse x function is having derivative as 1 over 1 plus x square. So this thing you have to keep in your mind. So if I put this function as t and take its derivative, then you can solve this question. So I will make the substitution here, that a here is a constant. A tan inverse x, suppose this is equal to t. Now differentiating both sides, 1 over, this is the derivative of tan inverse x, is dx is equal to dt. So after substitution, the question becomes e to the power a tan inverse x is t, and dx over 1 plus x square is equal to 1 by a dt. So dt and 1 by a is outside because this is a constant. So the answer is 1 by a e to the power t plus c. Putting the value of t again, this is the solution to the question. So here you have to keep in your mind that which function should be substituted so that it is the derivative of the other function. Now the next question is sine of log x divided by x dx. So here you can see that log x is the function, derivative of which is given in the question. Derivative of log x is 1 by x, that is given in the question. So I will substitute log x as t. So differentiating with respect to x here and t here is equal to dt. So I will put the value sin x, log x is t, 1 by x dx is dt. So the answer is minus cos t plus c, putting the value minus cos log x plus c. This is the solution to this question. So this type of integration is known as integration by substitution. Now we can take another example for this. This is the question. So here you can see that tan x, the function fx, and its derivative, in place of x we have root x. So derivative of tan is sec square and derivative of root x is 1 by 2 root x, that is also given. So I will substitute this function as t, and derivative of this and this is given. So let me substitute 10 of root x is equal to t. Differentiating both sides, sec square root x, this is the derivative of 10, and derivative of root x, 1 by 2 root x, or let me write this, dx is equal to dt. So this gives us sec square x over 2 root x dx is dt. So this is equal to now sec square x under root x, dx over root x is 2 dt. So 2, this is t4 dt. So 2 t to the power 5 by 5 plus c, the answer is 2 10 to the power 5 root x by 5 plus c. Now let us take another example. The question is integral x to the power x, x to the power 2x plus 1 into log x plus 1 divided by x to the power 4x plus 1 dx. This is the question. Integration of this you have to find. So first of all, we will make this substitution for this x to the power x. Why we are doing this? Because the numerator and denominator both involve the same function x to the power x, and we have log function also, that will be the derivative of this. How it is possible? See, if you put x equal to x is equal to t, taking log of both sides, log of x to the power x is log t, so x log x is log t. Differentiating both sides, dx is equal to 1 by t dt, or I can write 1 plus log x dx is equal to dt, t multiplied on this side. So put the value of t, x to the power x, 1 plus log x dx is dt. So x to the power x, 1 plus log x dx is dt. So this is t square upon this is t4 into dt, which can be further written as I told you previously, that in this type of problem you have to divide by t square both numerator and denominator. So this type of expression is self-explanatory. This function is derivative of one function here. So if you find what is the function, the derivative of this is 1 plus 1 by t square. So if I write here t minus 1 by t, in that if I get this in the denominator, the derivative of this d by dt of this is 1 plus 1 by t square, what we are having here. So I would like to find, or I will try to find here or write this denominator term in terms of t minus 1 by t. This can be written as square of t plus 1 by t and t minus 1 by t. So we will write this in terms of t minus 1 by t, t minus 1 by t whole square. So t square plus 1 by t square minus 2, so we add plus 2. Now you can substitute this again. So t minus 1 by t is equal to z. So 1 plus 1 by t square dt is equal to dz. So this is equal to dz over z square plus 2, or dz over z square plus root 2 whole square. So this is of the form dx over x square plus a square is equal to 1 by a tan inverse of x by a. So 1 by root 2 tan inverse of z by root 2, putting the value of z, t minus 1 by t by root 2 plus c. Now put the value of t square minus 1 by t root 2. So t was x to the power x. So x to the power 2x minus 1 by x to the power x root 2 plus c. This is the answer to the question. So here you have to identify what substitution you have to make, and that can solve the question. These questions are very simple or easy to solve if you can identify what the substitution should be. So let us solve next question from this. The next question is x square minus 1 dx over x4 plus 3x square plus 1 tan inverse of x plus 1 by x. So we have to solve this question. So I told you previously also that in such type of cases the algebraic expressions, that is the polynomial expressions in numerator and denominator, must be divided by what? So here we have x square, here we have x4 and x square, so it must be divided by x square, this and this both, and not this expression, because we cannot divide this. So dividing by x square, numerator and denominator, 1 minus 1 by x square upon x square plus 1 by x square plus 3 into 1 over tan inverse x plus 1 by x dx. Now see, as we did in the previous case, this can be written as x square plus 1 by x square plus 3. Here we have minus sign, so I will write here this as derivative of x plus 1 by x. This will solve the case, as here also I have x plus 1 by x. So whole square of, I am making this as perfect square, x plus 1 by x whole square, and this will be x square plus 1 by x square plus 2, so plus 1. Now I can substitute x plus 1 by x is equal to t, differentiating both sides, 1 minus 1 by x square dx is equal to dt. So the integral becomes dt divided by, you will write here x plus 1 by x whole square plus 1, so t square plus 1 and tan inverse of t. Now the problem again involves two functions, fx and gx. Derivative of fx, tan inverse t, is 1 over 1 plus t square. So I will substitute again tan inverse t is equal to z. So 1 over 1 plus t square dt is dz. So this is dz over z. This is z. So the answer is log of magnitude of z plus c. So putting the value of z, tan inverse t plus c. Put the value of t, tan inverse of x plus 1 by x plus c. So this is the solution to the question. Again, you can see that it is very easy to solve the question. Let us move on to the next question now. The next question is this is very easy question. Sin x has a derivative of cos x. Cos x has a derivative of minus sin x. You can substitute any of these. If I put sin x equal to t, cos x dx is dt. So sin x is, now here we have cos square x. So you can solve the question by another method also, or if you do it like this, then you will have to write this either 1 of cos has to be written in terms of sin square x or sin has to be converted into cos square x. So you can do it by this method, or you can do it by the method of writing this in terms of sin cube x as a function of sin 3x, cos square x as a function of cos 2x, and then solving by multiplying. So I can write this as sin square x, cos square x I can write 1 minus sin square x, and 1 of the sin x I can write here dx. So this all becomes in terms of sin. So you can solve it by this also, or you can write here in place of cos square x 1 minus sin, so let it be cos square x. So I can write cos x as t, so minus sin x dx is dt. So this will be dt, cos x is t, sin square x is equal to 1 minus cos square x into cos square x sin x dx. So this is minus of dt, and this is 1 minus t square, cos square is t square dt. So minus t square minus t4 . So this is minus cos cube x by 3 plus cos 5x by 5 plus c. Now let us move on to the next question now. The next question is sin x over sin of x plus a dx. So here we can write x plus a can be substituted is equal to, suppose, y. So dx is dy. So sin x here is equal to y minus a. Expanding this, the formula of sine A minus B, and divide by sine Y, then sine A cos B minus cos A sine B divided by sine Y. So this is integral of cos A dy, sine Y cancels, minus cos by sine cot Y sine A dy. Cos A is a constant. A is a constant here. So integral of dy is y cos A, minus sine A here is a constant, and integral of cot Y is equal to log sine Y modulus plus C. So you can put the value of y, x plus A cos A minus sine A log sine modulus of sine of x plus A plus C. Then next we have dx over 1 plus 10x. This is the question. So you can solve it by converting it to sine and cos also. Write 10x is equal to sin x divided by cos x. So cos x over cos x plus sin x dx. So if I substitute the term in denominator, cos x plus sin x is equal to t or y, then its derivative will be cos x minus sin x. So I should try to obtain cos x minus sin x in the numerator. So how do we get cos x minus sin x? This can be written as 1 by 2 cos x over cos x plus sin x dx, which is further cos x plus cos x, and here I will add sin x, and here I will add minus sin x. Now you can divide numerator by denominator. This by this you will get 1 plus 1 by 2 cos x minus sin x over cos x plus sin x dx. This will be cancelled. So this is x by 2 plus 1 by 2. Now here if you substitute this, the derivative of this is given here. Cos x plus sin x is equal to t. So the derivative is minus sin x plus cos x dx is dt. So this becomes integral of dt by t, which is log of mod t plus c with 1 by 2. So 1 by 2 log of mod of t, and t is cos x plus sin x plus c. This is the answer to this question.